All right, welcome. Let's go ahead and finish up the last few problems here from our midterm. All right, so looking at problem 31, it says find the correct end behavior diagram for the given polynomial function. So we kind of have this picture to kind of help guide us. This should be a good thing to add to your note card. So the coefficient tells us what the right is doing, and the exponent tells us what the left is doing. Now let's make sure we really get detailed about this, okay? On this number, we're looking for whether or not it's positive or negative. Okay, if it's positive, then you know that the right goes up. If it's negative, then you know that the right goes down. All right, now as for the exponent, I don't care about positive or negative. In fact, it'll never be negative. The polynomial can't have a negative exponent, but it could be even or odd. So if it's even, then that means that the left and the right do the same thing. Okay, so they'll do the same. If it's odd, then you know they're going to do the opposite. So lots of ways to remember these. I think of the two O words, odd opposite. But another way to remember it is just to think about two of our famous graphs that we know, right? If we have an x squared, we know that the left goes up and the right goes up, right? So they match each other. But if we have an x cubed, which looks like this, then we can see that the left and the right are not doing the same thing, but they're doing the opposite. So even they'll match each other, odd, they'll do the opposite. All right, so knowing that, let's go ahead and use our leading term test to see what's going on with the given polynomial. So as long as your polynomial is written in standard form, that means highest exponent to lowest exponent, then this front term, that's what we're going to use in our leading term test. Okay, so make sure it does go from highest exponent to lowest exponent. So we're going to take a look at this 1/7 x to the third. Now, as we can see, for this number, since it's negative, right, that implies that the right is going to go down. I'm just going to put right down. All right, so if we look at the multiple choice, A has the right going up, so that's out of there. B has the right going down, so maybe. C has the right going up, so no. And D has the right going down, so maybe. So it looks like we do need to proceed and look at the exponent. Well, we can see that this is an odd number, so we know that the left and the right should be doing the opposite, right? Okay, so it can't be D, they're doing the same there, they're both going down. So it looks like the correct answer is going to be B. All right, let's take a look at number 32. Find the zeros of the polynomial function and state the multiplicity of each. So in order to find the zeros, you're going to have to let y be 0. So we're going to make that f of x 0. And who knows how you'll solve this? It could be factoring. It could be quadratic formula, right? In this case, it's going to be factoring by grouping. So I see those four terms. I'm going to try our slice and half method. So I'm going to pull out the GCF, the greatest common factor, from just these first two. And I can see that I can pull out an x squared from both. So that's going to leave me with x plus 1. Don't forget to always, if anything in your head, just remultiply and make sure it matches. So x squared times x is x cubed, and x squared times 1 is x squared. So they're looking good there. Now we can see that we're going to have to pull out a negative. And if we look at what they have in common, it looks like they both have a 2 that could divide into. All right, so this will just be x. And don't forget, whenever you factor out a negative, the signs change. So this will no longer be a minus. This will now be a plus. And again, if you just do quick redistributing to check, -2 times x is indeed -2x. And -2 times 1 is indeed -2. Always do that, just to check and make sure you're right. Okay, so we're going to factor out the x plus 1 from both terms. We can see they have it in common. It's here and here. And once I pull it out, the leftovers are going to be the x squared minus 2. So now we're at the point where we set each piece equal to 0 using the zero product property. Anything that multiplies to make 0, if two things multiply to make 0, then one of them's got to be 0. All right, so let's go ahead and solve these. So we'll subtract 1 from both sides to get the x by itself here. We'll get -1. And then we will add 2 to both sides. And one thing you got to remember when you're square rooting to get rid of the squared is don't forget to put plus or minus. And if you do your check as far as the exponent is concerned, right? We should have 3 solutions if we're going to have a highest exponent of 3. And we do have 3 solutions if we put the plus or minus on it, right? We have -1, which is 1. And then we have, oops, I forgot the square root, you guys, don't mind me. We have positive root 2 and we have negative root 2, okay? Now, the multiplicity for all of these is going to be 1 because that is the exponent on the factor. Plus, if you think about it, you couldn't possibly have a higher multiplicity because if each one counts once, you've already got your 3. Remember, you can't go beyond the highest exponent. So multiplicity of 1 for all zeros. Okay, so I think we answered everything it asked for on this. All right. Let's check out number 33. Graph the function. We're basically going to do the last 2 problems together. It's kind of a nice sequence of problems because it leads us right into this one. Okay, so we're going to set it equal to 0 to find the zeros. And I'm going to factor an x squared out of both. So that leaves me x squared. Then we're going to set each piece equal to 0. Now you can set the x squared equal to 0, or you can just set the x equal to 0. The exponent doesn't really matter. Because 0 to the second power is still 0. So you can see right here, we're going to get x equal to 0. So moral of the story, you guys, you have x to the 5th. You don't have to set x to the 5th equal to 0, just set the x equal to 0. Do that. Okay. If the base is 0, then no matter how many times you raise it to a power, it's still 0. All right, and now we're going to set x minus 4 equal to 0. Let's add the 4 to both sides. So we get x equals 4. Now, there's a difference in multiplicity on this one, right? Look at this. We have a 2 here and a 1 here. So this one is going to be multiplicity 2. This one is going to be multiplicity 1. And remember, why we care is because the graph is going to behave differently, right? It's just going to cross through when it's a 1 for its multiplicity, or any odd it's going to cross. But it's going to be tangent or a touch point, whatever your textbook says. I prefer the language tangent, whenever you have an even multiplicity. So it won't cross, okay? Or they call it a bounce point in some books, but we'll use the word tangent. Okay, I'm going to go ahead and mark those on my graph. So 0 and 4. Okay, now we're going to use the leading term test also. So the leading term is x cubed. I'm going to write it as 1x cubed, just so I can really see that front number. Now, since the front number is positive, we know that the right goes up. And then when we look at the exponent being odd, we'll remember odd means that they're going to do the opposite. Okay, so if the right goes up, that implies that the left goes down. Okay, so let's see if we can graph this. Don't forget, we're tangent at 0. Okay, so I'm going to come up to 0 and I'm not going to cross. I'm going to turn around, right? And then I'm going to cross through here. So you can see this graph that I've drawn. It's kind of shaky, but it gets the job done. It goes up to the right and it goes down to the left, which is exactly what we want. And then it is tangent at x equals 0, but it crosses through x equals 4. So you just have to hunt this down from a lineup of graphs. Let's go see if we can hunt this down. Okay. Ooh, it looks like it could be C. Let me go up here and make sure there's no others. Yeah. So it's kind of small. Sorry, you guys, we can zoom in a little bit. But if you look at C, it's going down to the left, it comes up and it's tangent at 0, but then it crosses through 4. So C would be the graph that we're looking for on that one. All right, moving right along. Let's try 34. Hey, it's nice when the directions tell you exactly what to do, but telling us to use synthetic division. Now, one thing to remember is every single term has to be present. So we have our our cubic term, our x cubed. We have our squared term, our quadratic term, but we're missing our linear term, our x to the first. So we'll add a 0x to the problem. So that way we have 3, 2, 1, and 9, right? Now, that means that in our synthetic division, we are going to have 1, -1, 0, and 5 across the top. Now remember, to figure out what's going to go in the box, basically set this equal to 0, which is the same as doing the opposite. If you set x plus 2 equal to 0, notice you're going to subtract 2. So it's going to end up being the opposite always, because we have to do opposites here to make it cancel. Okay. All right, so let's go ahead and do our synthetic division. So remember, you bring down the first term, or the first number, and then it's just multiply, add, multiply, add, multiply, add until you get to the end. So we're going to multiply -2 times 1, and then we're going to add downward. So -1 plus -2. Then we're going to multiply, a negative times a negative is a positive, 2 times 3 is 6. And then we're going to add downward, 0 plus 6 is 6. Then -2 times 6 is -12. And when we add downward, 5 plus -12, it's going to be 7. Okay, so it says find the quotient and the remainder. Now remember, whatever exponent you had, you're going to go down a degree because you divided by an x to the first by a linear term. So it's only going to shrink it by 1. So instead of being a cubic, we're now going to have a quadratic. So our answer here should be 1x to the second minus 3x to the first plus 6. That's going to be our quotient, although they usually don't write the 1, right? And then our remainder is going to be, our r of x is going to be -7. I guess I should call this q of x for quotient, right? Hey, only 2 of them even had a remainder of -7. So these guys were goners anyways. And it looks like the answer has to be C, because that one has the correct quotient. All right. 35. So let's find our vertical asymptotes. So on your note card, you probably want to put down the process for finding vertical asymptotes. So step 1 is you want to factor. Step 2, you want to cancel. And in step 3, you're going to set bottom equal to 0. That's our process for finding the vertical asymptotes. Okay. All right, so let's go ahead and start with the factoring. So I'm looking at the numerator and I'm noticing they both have an x. I'm going to pull out an x. Give me x plus 4. For the denominator, we're going to have to use the x method. So we're looking for factors of the last number, -24. The things that multiply to make -24, that add up to the middle number of -2. So they have to multiply to make -24 and add to make -2. So just start writing down things that multiply to make -24, right? Like 3 times 8, 8 times 3. I mean, it's going to be 6 and a 4 because we need to have a difference of 2, right? So either it's -6 times +4 or -4 times +6. And since we want it to add up to -2, it's got to be this one, right? Remember, the bigger number should match signs with that bottom number always. Okay. All right, so if we put that in here, we got x minus 6 and x plus 4. So you must know your sets, because a lot of people just set the denominator equal to 0 and they'll miss this because the x plus 4 actually cancels out. So the only one we're going to set equal to 0 is going to be the x minus 6. Okay. So we get x equals 6. It's our only vertical asymptote. Look how scary. There's that -4 there too, thinking that you might accidentally set this guy equal to 0. So don't forget that cancel. Okay. All right, you guys, last one on the review. All of this stuff that we're doing as far as these asymptotes is so important moving on into trig and into calculus in a big way too. Calculus, you're going to be finding limits, and definitely knowing these rules can help you find your limits. Okay, so let's just kind of go over really quickly your horizontal asymptote possibilities. All right, there's three things that could happen. Either you could have a smaller denominator, smaller bottom, or you could have a bigger denominator, or your numerator and denominator could be equal. Okay, so what we mean by that, just with an example, is maybe like an x to the fifth over an x to the sixth. That would be small bottom. Big bottom would be like the flip of that. Okay, now the x to the fifth is in the bottom. We're comparing highest exponents, right? Highest exponents. There might be more, right? Plus, blah, blah, blah. But we don't care about that. We're just going to look at the highest for each, okay? Or maybe they're equal. Maybe you have an x squared on top of it. All right. In the case of small bottom, there is no horizontal asymptote. In the case of big bottom, it's going to be the x-axis y equals 0. In the case that they're equal, so let me put some coefficients here just to make this interesting. Let's say we have 2/3, then it's going to be a ratio of the leading coefficients. So that's going to be your answer, y equals 2/3. Okay, so this would be a good thing to have on your note card. Okay. All right, so we have to figure out which case we have. So I'm looking at the highest exponents and I see 2 and 2. So we have the equal case, right? So we're going to go ahead and circle the leading coefficients. There's a 1 here, so this is really 5/1, right? Which means 5 divided by 1, it's just going to be y equals 5. What do you know? That's their great sign. All right, you guys, hopefully this helps you out. Study this over and over, like take the test over and over without having the video out. Grade yourself, see which ones you missed, go to the video to get help, and then print a new blank test and try it again and see if you get those ones right now without any help, except for maybe your note card and a calculator. Don't study with the videos out because you'll think you have it when you really don't. The only way you're going to know if you have it is by having the supplies out you're allowed during the test. Okay, so not your notes for the semester, no videos, right? Just you, your note card, and your calculator. All right, you guys, thanks for joining me. Have a great day.